Other challenges were obtaining permission from the neighbors and the town to place the wells so close to the property line. The general contractor, Tribeca Builders, did a great job communicating the project plans and working with all parties to meet everyone's needs. They erected special sound barriers during drilling, and prior to drilling even brought a well rig in for a test to alleviate concerns that the noise levels may impact local businesses. I believe the project team did a very good job with that and worked with all parties to the best of their abilities, resulting in the project going forward. The wells have been drilled and the geothermal heating and cooling system is nearing completion. I look forward to witnessing the fully functioning system and visiting the theater for a performance in the near future.
The wells. There are 4 of them. All together pump groundwater into the building at 55 degrees. Water to the water heat exchanger. That's the building water to water heat exchanger. Then return it back to the well at different seasonal temperatures. The inside water is piped to heat pumps and air handlers in the attic, one of the few places with barely enough room. There is a saying called Murphy's Law on a project. If something can go wrong, it will go wrong. Here we have Pat talking about how his team solved all of these and other perplexing problems like precision cutting openings in the roof in order to install the heat pumps and air handlers that mix fresh air in the attic.
Living in Norwood since my family moved here from Ireland and having seen shows at the Norwood Theatre, I was very excited as a local contractor to be involved with the renovations. As the owner of McDonough Construction, I felt this project, unlike any other project we have worked on, would give my company a new perspective on geothermal heating. Our contribution to the geothermal heating was helping Superintendent Richard Daly resolve the logistics of laying out all the wells around the building, coordinating the lines with DigSafe, and marking of existing power and existing storm drains within the property lines. Together we also worked, after much thought, how to get the roof and attic prepared for the geothermal heat pumps and how to get the energy recovery units on the roof. After coordinating with the engineers and HVAC contractors, my team of carpenters modified the structural rafters to precisely accept the heat pumps. The plan went so well that when Bosco Crane Company came to set the units, we were done in less than a day. My carpenters and I also worked hand in hand with Don O'Brien to be sure the interior walls showed no sign of all the geothermal work done behind them. I'm looking forward to bringing the family to the show and enjoying the comfort of the geothermal engineering.
Don, our superlative sheet metal worker, explains how he connected ducts from the front to the back. Then the attic metalwork for gently dropping the cool air during the summer, and also ductwork for supply of heated air from under the floor to rise during the winter months. You won't see his work, but you'll be able to enjoy it.
My name is Don McNeil. I work for Kennedy Sheet Metal in Weymouth. I'm one of the guys who installed the air ducting systems. I've been a sheet metal worker my entire life, graduating from Weymouth Vocational Technical High School in 1973. I've been with Kennedy for the last 26 years, both in the office and installing on the job. This is the first geothermal project I've ever been involved in. There were many challenges on the Norwood Theatre project over and above those usually encountered on a renovation of this nature. Faced with a building constructed in the 1920s and not having the space allotted for the mechanical utilities required in today's world for heating and cooling. There is over 2,000 linear feet of ductwork, most of which is crammed into the attic. Add in the electrical, plumbing, mechanical piping, and fire protection, and it's pretty crowded. Keeping the original architecture intact was extremely important and added to the level of difficulty. The theater required 110 tons of cooling, which is an engineering term, not how much the equipment weighed. There are 9 heating cooling units in the attic and 6 energy recovery units on the roof. The energy recovery units are tied together to the units in the attic. The units in the attic had to be lowered in through the roof by a crane. placed directly onto their support frames that were isolated from the building structure so you wouldn't hear them when they're running. The roof had to be cut open, the units placed, and the roof repaired all in one day in the beginning of January. If it was last year when we had a basic New England winter with lots of snow, I don't think it would have happened. The roof is sloped and not flat, and it would have been unsafe for the carpenters and roofers to be on it. The holes in the roof were about 8 feet by 8 feet to give you a sense for the physical size of the operation. After the equipment was in place, it became really challenging to final connect to the ducts as the space was extremely cramped, and in some cases, ductwork had to be assembled in place instead of in the shop. The level of cooperation between the different trades, electricians, sprinkler fitters, pipe fitters, plumbers, carpenters, and sheet metal, had to be high, and it was, showing that non-union and union tradesmen can work together. I wonder what it must have been like for the original workers building the theater. Seeing the steel trusses in the attic that were hot riveted together, the arched plaster ceilings, and all the ornamental plasterwork around the edges, you get a sense of the old school craftsmanship. I think this old theater has brought so much pleasure to so many people over the years that somehow it played a part in the construction process. While we were all in some very tight places and awkward positions, there was no dissension between the workers. In fact, every day you were greeted with a "Good morning, how are you?" by just about all the guys on site that day. The friendliness, I believe, stems from the very soul of the theater. Good vibes breed happiness at the Norwood Theater.
Even though electrical foreman Paul tells of a tenfold increase in the electric power he helped supply to the theater, most of that increase will not be used by the geothermal pumps when compared to conventional HVAC energy use.
Hi, my name is Paul Duborowski. I'm the electrical foreman for T&T Electrical at the Norwood Theater project. I've been working on this project for a year now. We're on schedule to open this summer. When I first arrived on site last year, the theater was running on a small 200 amp service, which many homes have. We've upgraded tenfold to a 2,000 amp service with 15 different panels. This required Norwood Light and Power to upgrade their system as well to handle all the upgrades the theater needs. This includes power and lighting for a major music concert, high-tech lighting and temperature controls, new fire alarm, a backup generator, and power for the new heating, ventilation, and air conditioning system. Part of the new HVAC upgrade was the geothermal tie-in, which was added several months into the project. Geothermal added 4 3-phase well pumps outside the building that my crew installed piping to protect the wiring long term. Inside the building, a series of VFD, which is variable frequency drives, motor speed controls, were added to maximize every watt of efficiency out of the pumps to minimize operating costs. Additional pumps were required to circulate the geothermal water to the 20 heat pumps throughout the building.